All right, welcome to the video. This one is on chapter 9, heating systems. Now, it's just a couple things that I find interesting that I like to talk about. And I think that an understanding of some basics about heating is important when you are trying to grasp the more technical stuff. Now, the technical stuff, in order to keep these videos, as I said in the other video, from being hours long, I'm going to let you read those on your own. Any questions, please reach out, okay? But I think the book does a better job explaining it than I could, all right? So here's the thing. Heating. A lot of things that influence our comfort, right? Warmth, how we feel warm and comfortable, all right? If we're too hot, we're not comfortable. If we're too cold, we're not comfortable. But there's something other than just that temperature, okay? If it's 80 degrees outside, is that too hot? Well, it depends. Depends on a lot of things, right? Depends on mainly who you are, but also significantly on the amount of humidity. Now, what is humidity? Simply water in the air. Now, when we're talking about heating systems, and cooling systems for that matter, we're talking about humidity as, in a way, as it's represented by percentage of water in the air, okay? So, percentage of water in the air. So you've heard before these days of, it's 90% humid and 100% humid. I never really wrapped my mind around that. I thought it was kind of silly because it was like 100% humidity in my mind is water. You're walking through the ocean or whatever. All right. But it's represented a little differently than that. It is percentage of water in the air, but percentage of the water in the air to the point of when that water would be too much for the air to handle and become water, actual condensation, rain, if you will. All right. So when you're outside and you're breathing in, you feel that dampness and you're sweating really good. There's a lot of water in the air, but it hasn't reached that point where it becomes back to a liquid. It's still a gas, if you will. It's still suspended in the air. All right. If it reaches more than 100%, then it becomes rain. All right. So that makes more sense in my mind, and I hope it does in yours. So that term, how we classify humidity in that way, is called relative humidity. So you have an RH factor 90%, RH 80%, whatever. The ideal comfort zone is between 20 and 60% RH. All right, an RH of 20 to 60%. Now, ideally, and again, it depends on the personal preferences of people or whatever, but generally around 40 is what we want, okay, especially indoors, all right? So that is a very big part of how we feel comfort, all right? Now, let's talk about how we feel heat, all right? And again, these are concepts that I think are important to at least to wrap your mind around when we're trying to decide on heating systems, okay, to make decisions on the sizes that we need and the things that we need for our specific property. And quite frankly, there's a lot of different choices, and it would take a long time to go through every single one. But if we understand the humidity piece, and also how heat is transferred, then we're better suited to make wise decisions, right? So how is heat transferred? There's 3 different ways to transfer heat. Now, those of you who are in have culinary background, have probably been taught that because the same way we're heating our bodies inside the house, those same 3 methods for heating our bodies is the same 3 methods that we use to cook our food. All right, just a little bit more intense. We're not cooking our bodies, hopefully. All right, so it's the same 3 transfer methods, and they are radiant, conduction, and convection. All right, so radiant, conduction, or conductive, and then conductive heat, or convective or convection. Okay, so those transfers are the 3 types. Now, when I say transfers, I'm talking about here I have a heat source. Okay, I have a heat source right here, and I have the person that needs to be heated right here. All right. Now, how is the heat? Let's do this. Which I'm looking at it backwards. All right, so which one's which? Okay, so this is the heat source and this is the person, right? So it's heating, all right? Let's say it's a fire, okay? So how is that heat from that fire, right, coming from here to our people that need to feel comfort, like when our little toesies warm, right? How does that happen? How does it get from here to here? It is transferred in one way, one of the three ways. The first one being radiant. Radiant is basically here. Which one's which? I think this was my source, right? My source, okay? My people, or me, or object that I need to heat, whatever it is, all right? Radiant heat is simply heat waves, infrared waves, heat waves, many different things, but waves of heat that are coming straight from the source and touching the thing that needs to be heated. So when we by a fire and we get close to it, we get to the point where we can feel it on our skin, right? If you were now, that's very effective heat, right? So why not have every heating system radiant? Well, there's a reason. So we have the source and we have our people, but then we have a wall in between. Okay, radiant heat source heats what it touches. It's heating this wall. All right. Now, if this wall is a solid piece of steel, eventually it will heat this, and this becomes now a heat source, and then it can radiate and touch the people. But if it's like a normal wall in a house, which has got a 4-inch airspace, that radiant heat stops. All right. So if you're relying solely on radiant heat, and there's many obstacles, walls and furniture and other things in a space, it's not that effective. Okay. Now, it can eventually turn into another type of heat transfer, but we'll get to that in a minute. So that's radiant heat, okay? The next one is conductive heat, okay? Conductive heat is actually heat source, thing that needs to be heated, okay? It's only conducted heat when, or heat transfer when they're touching, okay? Heat source, thing that needs to be heated, it's touching. In cooking, right, we put a pan on a heat source, an eye of a stove, that is conductive heat, all right? Even if it's gas, the heat source is touching the thing that needs to be heated. And then the meat is on that pan, and that's conductive. So you have conductive transfer to the pan and conductive transfer to the meat, okay? All right? So how does that do us any good? We can't have warm walls where people need to cuddle up against the wall in order to be warm. Well, that's true. However, there are some examples of conductive heat in personal comfort. The first time I got a car with seat warmers, it freaked me the heck out, right? I'm not really keen on it. But a lot of people, the idea of sitting down on faux leather that's been outside at 10 degrees below zero or even 20 degrees above zero is not pleasant. So you have the key fob or the app on phone or whatever, and you turn on that seat heater and you sit down on it, it's nice and warm. Now that warmth that we feel from that seat heater is conductive. My butt, the heat source, which is my seat, that is conduction, okay? That's a good way to explain it, hopefully. All right, so the next one is convective or convection. Convection is basically heating of air, okay? So it can happen naturally. We have a room and we have that radiant heat source, right? We have a heat source, it radiates. Now, I told you that radiant heat heats what it touches. Well, one thing it touches is air, okay? So it touches air, and what happens to air when it gets warm, all right? It becomes lighter, which means it rises, okay? So you have this square or this cubed room, right? You have a heat source down here on one side, on the floor, hopefully, because that's the best, most effective, and I'll explain why. So you have that heat source there. The air that's there gets heated. What does it do? It goes up, all right? It goes up because it's lighter than cold air right now, right? Hot air rises, so it rises. Now, is it going to stay up there? Is it going to go to the Netherlands, to the atmosphere? No, because what's it going to do? It's going to cool off. So when it cools off, it comes back down, all right? So natural convection basically is heat goes up, moves the air. They heat the actual fact that some air is being heated and then being replaced by cooler air as that air disappears, and then that one comes down when it cools, where the ones that replaced it now is warm and now it's going to be cool. So it's a cycle, as you can see, right? So that is convective heat. So when we have radiant heat, like baseboards or some electric heaters are radiant, radiators, right? That the word radiant is in the name, right? So you have those radiators, that's what they're doing. They are basically providing comfort that when I'm line of sight to it, it's actually touching my skin, but it is also creating some type of convection, okay? But true convective heat and convective ovens, convection heat and convection ovens, basically are assisted by airflow through a blower. All right, so you have a heat source that traps a lot of radiant, bounces radiant heat back and forth from different, heats one, the source heats one piece of metal and it bounces back and forth. And then a blower forces outside air or recirculated inside air. It forces cooler air through that, and then it comes back out as warm air. Now it's warm air in the room and it feels great. Right? But eventually what's it going to do? Right? It's going to cool. So that means it comes back down and then the cycle returns. So you will see on a forced hot air system, you will see that the heat source, the blowers where the heat comes out, is in it should be, I mean, unless it's totally wrongly engineered, in the bottom of the floor somewhere. And then you have those vents in the roof, those are the returns. So the hot, cold air goes in there and it comes back down and it cycles, right? Now, I always get a kick out of it. I see people trying to warm their hands on the return air. Doesn't happen very often, but some folks do that. All right. So the hot air is what comes down from the bottom. All right. So this was just a quick idea of basic functions, a basic theory, if you will, on how we heat. Okay. So the technical stuff, I'm going to leave it to you in the book. All right. So let's have a good week. The next video is going to be on loads, heating loads and cooling loads, because they're very similar, and I didn't see the point in separating them. All right. So look forward to that.